Common tangent. Now let's see the equation of common tangent. As we all know what a common tangent is. A tangent which acts for both the two circles is what is a common tangent. Now if I have, say, two touching circles, this given by equation s equal to 0 and this given by the equation s dash equal to 0, then this is the common tangent between the two circles. That is, T acts as the common tangent to the two circles. Then how do we find the equation of T is the biggest question here. The formula for finding equation of common tangent T is, we have s minus s dash equal to 0 is the equation of common tangent, which is given by s minus s dash equal to 0, or this can also be given as s dash minus s equals 0, is how we understand the equation of common tangent for the two circles. Now there's other possibility that I have the two circles touching internally. Then in this case I have the common tangent this. So this also is given by the equation s minus s dash equal to 0. So let me have a circle in general form as s equals x square plus y square plus 2gx plus 2fy plus c equal to 0, and let me have a line L given by lx plus my plus n equals 0. Now with this basic information of a circle and a line, if I say that there is a circle and there is a line which intersects the circle at here, so this is the circle and this is the line which intersect at 2 points, say A and B. So if I have a condition where a line is intersecting the circle forming a chord, then in this case the equation we have system of circles which we have taken as the heading. The introduction of system of circles is very important because when we discuss about these kind of situations where a line intersects a circle, there are system of circles which can be formed using this chord AB. So initially if I want to find the equation of a circle passing through AB, say for example I want to find equation of a circle passing through this chord AB, or I want to find another equation which is like this. So like this, we have different types of circles which can be formed using AB as the chord. So one of the circle is this, one is this. There might be one more circle which can be formed like this. Etc. So we have system of infinitely many circles which can be formed from the chord AB. So this infinitely many circles form a system which you're going to see as a formula. Therefore, equation of the system of circles passing through A and B, that is the points of intersection of the line in the circle, which is A and B, passing through A and B, equations of the system of circles passing through the points of intersections A and B is given by S plus lambda L equals 0, where lambda belongs to set of all real numbers, is how we understand the equation. So system of infinitely many circles which can be formed passing through A and B is given by S plus lambda L equal to 0, where lambda is a real number and this lambda is called the parameter, because this value of lambda decides what is the position of the circle which is drawn through A and B. So lambda acts as the parameter which measures the circle which is drawn through A and B. Is how we understand the system of circles S plus lambda L equal to 0, which is the equation of systems. Also, since lambda belongs to R and the set of real numbers is infinite, therefore for infinitely many real values of lambda, there are infinitely many circles which can be drawn passing through A and B. So therefore this forms an infinite system of circles. Therefore, since lambda has infinitely many values, of course belonging to R, therefore there exist infinitely many circles passing through A and B, which are the points of intersection of the line and the circle. So this plays a very important role in understanding the system of circles connected with the parameter lambda, so which states that since lambda has infinitely many values being real numbers, therefore there exist infinitely many circles passing through A and B. For each lambda there is a respective circle, and hence we form an infinitely many circles. Is how we understand the concept of system of circles connected with the parameter lambda belonging to real numbers. Similarly, let's identify the system of circles for two intersecting circles. In the previous case, it was a line which was intersecting the circle, and then we got a system passing through AB. Now here, let's see if we can form a system of infinitely many circles which can be formed for two circles which intersect. So let me take the two intersecting circles. So let me say this equation of this circle is S equal to 0, and equation of this circle is S dash equal to 0. Now, if suppose the points of intersection of the two circles is say A and B, then as in the previous case, the point of intersection of a line and a circle gave A and B. In this case, two circles intersect to give the points A and B. So if I can draw infinitely many points, circles through A and B. Suppose I would like to draw a circle passing through A and B, and then I would like to draw a circle passing through A and B, and then there's another circle with bigger radius which I would like to draw passing through A and B. So that I get infinitely many circles which can be drawn through A and B, which is called the system of circles. Now, the equation of this system, equation of system of circles passing through A and B is given by lambda s plus mu s dash equal to this, where lambda mu are the real numbers such that mu plus lambda is not equal to 0, is how we take the condition. Now the parameters here are lambda and mu, which define the system. So there are two parameters which define lambda associated with circle S equal to 0 and the parameter mu which is associated with the circle S dash equal to 0. This is how we define the system of circles for intersection of two circles S equal to 0 and S dash equal to 0. So now that we have the two parameters mu and lambda which are involved in the system of circles formed for the two intersecting circles, now next let's reduce that to a single parameter. So with the formula as we have seen here, which is lambda s plus mu s dash equal to 0, assuming that lambda is not equal to 0 implies I divide the whole equation with lambda, so that I get lambda s plus mu s dash divided with this gives me this, strictly because I assume this non-zero. So this on further simplification gives lambda s by lambda plus mu s dash by lambda equals 0. This on cancelling, since lambda is not equal to 0, I further get s plus mu by lambda of s dash equal to 0, where mu by lambda is not equal to minus 1. So let's see why this is not equal to minus 1 in the future cases. Let k equals mu by lambda, which belongs to real number, because mu is a real number and lambda is a real number. So the ratio of two real numbers, which is k, is also a real number. Therefore, this reduces to s plus ks dash equal to 0 is the new system of circles for k belonging to R, is how we understand the two parameters reduced to a single parameter k belonging to real numbers. The system of circles with single parameter k is s plus ks dash equal to 0. In the previous case, we have defined the system of circles for two intersecting circles as s plus ks dash equal to 0 with k which is assumed as not equal to minus 1 belonging to R. So what could be the reason that k is not equal to minus 1 is the biggest question. So what if k is equal to minus 1 is the biggest question here. So in order to just investigate on why k should not be equal to minus 1, let's take the contradictory of assuming that k equal to minus 1 implies this reduces to s plus k, which is equal to minus 1 times s dash, which is equal to 0. Then in this case, I get this to be s minus s dash equal to 0. But s minus s dash is already known to be the common chord of the two circles, that is a line. A common chord is a line. Therefore, for k equal to minus 1, we get a common chord which is a line. But we want the system of circles. Therefore, we have k not equal to minus 1. Therefore, for system of circles, k is not equal to minus 1 is how we understand this concept. K equal to minus 1 implies the system reduces to this, which is the common chord or the common tangent for the two circles, and hence it reduces to a straight line, which is a contradiction. Therefore, for system of circles, k is not equal to minus 1. The limitations of k is that k is any real number except minus 1. Now let's do some problems connecting the system of circles. So in this case, we have, say for example, a problem where I want to find the equation of circle which cuts the circles x squared plus y squared minus 4x minus 6y plus 7 equal to 0, and also it cuts x squared plus y squared minus 10x minus 4y plus 21 equal to 0. So we have to find the circle which cuts this and this orthogonally. And has its diameter on the line 2x plus 3y equal to 7. So in this case, there are three conditions given: that the circle which I need to find is cutting this circle at 90 degrees, this circle also at 90 degrees, and it is having its diameter on the line 2x plus 3y equal to 7. So using the three conditions of this, this and this, I am going to find the equation of the circle. So let's see how we can find the equation of circle using the three basic conditions 1, 2 and 3. Now initially, because I don't know the equation of circle, let me take the equation of circle in general form. Let the equation of circle be S equals x squared plus y squared plus 2gx plus 2fy plus c equals 0. So this is the equation of circle in general form, which I take as equation 1. And next I take this as equation 2 and this as equation 3. So with three equations 1, 2 and 3, I use the condition that this circle is cutting this orthogonally. In general form, we have a formula or the condition for orthogonality, which I am going to apply in case of this circle cutting this at 90 degrees. Similarly, this circle cutting this at 90 degrees, I get one more orthogonal condition which I am going to apply. So let's see how we can apply that. Now with the given problem, we assume that with the circles that if I would like to find the equation of the circle which cuts the circle with equation 2 and the circle with equation 3, then the circle which is cutting this orthogonally, that is at 90 degrees and at 90 degrees, then we have to find the circle which cuts this circle at 90 and this circle at 90 and has its diameter on the line 2x plus 3y equals 7. So the diameter should lie. So if I assume this conditions, then we get a picture on how we need to solve this problem. So one is, this is orthogonal to the given to the circle we need to find, and this is orthogonal to this, and the diameter lies this on 2x plus 3y equal to 7. So using this condition, let me say S, this is the equation of circle in general form as S equal to 0, which I have taken as equation 1. Now 1 is orthogonal to 2, that is perpendicular, implies the condition is 2gg dash plus 2f dash equals c plus c dash. We have this condition in the formula. So with this condition, I have 2gg dash, that is my g is from this, and my g dash is minus 2 plus 2f, f dash from here is minus 3, that is equal to c plus c dash, which is 11. This on simplification gives minus 4g minus 6f is c plus 11. This on simplification gives me 4g plus 6f plus c is negative 11. So I assume this to be equation 4. So this is equation 4, which I have obtained by taking the orthogonal condition of one orthogonal to equation 2. Similarly, the second case of one orthogonal to equation 3 gives me another condition or an equation in G, F and C. So let's go with the second case. Now, similarly, 1 is orthogonal to 3 implies I get 2g, g dash in this case is half of minus 10, which is minus 5, plus 2f, f dash is half of this, which is minus 2, that is equals to c plus c dash. Now this on further simplification gives minus 10g minus 4f is c plus 21, which on further simplification gives 10g plus 4f plus c equals minus 21, which I take as equation 5. So this on simplification gives an equation in 3 unknowns g, f and c, that is 10g plus 4f plus c equals negative 21, which is equation 5. Now I take the third condition where the diameter lies on this line. The center lies on the diameter of the equation.